Cryptocurrency mining has transformed the financial world, creating decentralized systems that allow transactions to take place securely without relying on traditional banking institutions. However, as digital currencies continue to grow, so do concerns about the environmental impact of the technology supporting them. Traditional mining hardware consumes large amounts of electricity and creates increasing amounts of electronic waste. But the good news is that sustainable alternatives are emerging. In this video, we'll explore greener solutions for crypto hardware, from energy-efficient blockchain systems to responsible recycling practices and renewable energy adoption. Cryptocurrency mining has reshaped digital finance, giving people new ways to invest, transfer value, and participate in decentralized networks. But behind the innovation lies an important environmental challenge. Most traditional mining operations depend on powerful equipment such as GPUs or graphics processing units and ASIC miners, which are designed specifically for cryptocurrency mining. These systems perform complex calculations continuously in order to validate blockchain transactions. The problem is that this process requires enormous amounts of energy. Mining systems often run non-stop, consuming large amounts of electricity and contributing to carbon emissions, especially when powered by fossil fuels. At the same time, mining hardware becomes outdated quickly. Frequent equipment upgrades result in growing volumes of electronic waste, making sustainability a major concern for the future of cryptocurrency mining. Traditional crypto mining hardware presents several challenges beyond energy consumption. One major issue is rapid hardware obsolescence. Technology improves quickly, and miners constantly seek more efficient systems to remain profitable. As newer models become available, older machines often lose value and effectiveness. ASIC miners present an even greater challenge because they are designed for specific tasks only. Unlike general computer hardware, these systems cannot easily be repurposed for everyday use once they become outdated. The production of mining hardware also places pressure on natural resources. Manufacturing requires metals, rare materials, and energy-intensive processes, contributing to environmental impact before mining even begins. Recycling specialized mining hardware can also be difficult, leaving many outdated systems at risk of ending up in storage facilities or landfills. One of the most promising ways to reduce crypto mining's environmental impact is by transitioning to more energy-efficient blockchain systems. Traditional cryptocurrencies often depend on proof of work, or POW, which requires powerful hardware to solve mathematical problems and validate transactions. While effective, this system consumes large amounts of electricity. Alternative consensus mechanisms offer a more sustainable path forward. These systems maintain blockchain security while dramatically reducing energy consumption and hardware dependency. Lower energy requirements mean fewer mining rigs, less pressure on power grids, and reduced electronic waste accumulation. As innovation continues, sustainable blockchain technologies are becoming increasingly important in helping the industry balance growth with environmental responsibility. Proof of stake, commonly called POS, has become one of the leading alternatives to traditional mining. Instead of relying on computing power to validate transactions, POS selects validators based on the amount of cryptocurrency they are willing to stake as collateral. This approach removes the need for powerful mining rigs altogether. Because POS eliminates intensive computational mining, energy consumption drops dramatically. Networks operating under this system use only a fraction of the electricity required by proof-of-work models. Major blockchain platforms such as Ethereum, Cardano, and Solana have adopted or transitioned toward proof-of-stake systems, demonstrating that sustainability and blockchain security can successfully coexist. Perhaps most importantly, POS reduces electronic waste by decreasing reliance on constant hardware upgrades and specialized mining equipment. Beyond proof of stake, other alternatives are helping reduce dependence on traditional mining hardware. Proof of space and proof of capacity systems use storage space rather than processing power to secure blockchain networks. Instead of solving continuous calculations, participants dedicate available hard drive capacity to network operations. This approach dramatically lowers electricity demand compared to GPU or ASIC mining systems. Projects like Chia have shown how standard storage devices can support blockchain activity without requiring energy-hungry mining equipment. By reducing demand for high-powered hardware, these systems help extend equipment lifespans and reduce overall electronic waste generation. Some blockchain developers are taking a balanced approach through hybrid consensus systems. Rather than relying entirely on one method, hybrid models combine elements of proof of work with energy-efficient systems like proof of stake. This allows networks to maintain strong security while reducing environmental impact. By lowering dependence on heavy computational mining, hybrid systems reduce both electricity usage and hardware strain. These models also provide flexibility, allowing blockchain platforms to adapt to changing environmental and technological needs. As sustainability becomes a bigger priority, hybrid solutions may play an important role in shaping the next generation of cryptocurrency systems. Sustainability is not only about replacing mining systems, it is also about making better use of the hardware that already exists. Many mining components, particularly GPUs, can be repurposed for alternative applications instead of immediately becoming waste. Older systems may still support artificial intelligence projects, scientific research, video rendering, or advanced data processing. Some organizations are even integrating retired mining hardware into distributed computing projects focused on medical research and climate modeling. By extending the lifespan of equipment, businesses and miners can reduce unnecessary waste, lower disposal costs, and maximize the value of existing resources. Longer hardware life ultimately means less strain on the environment. Another important step towards sustainability involves improving how mining equipment is designed. Traditional systems are often replaced entirely when only one component becomes outdated or damaged. But modular hardware offers a smarter alternative. Upgradable systems allow miners to replace individual parts such as cooling systems, memory modules, or power supplies instead of discarding complete units. This design reduces electronic waste while lowering replacement costs for miners. Modular technology also supports a circular economy by making repairs easier and improving material recovery for licensed recyclers when equipment eventually reaches the end of its life. Smarter design can create better outcomes for both the environment and the mining industry. Reducing electronic waste is important, but sustainability in crypto mining also depends on cleaner energy sources. Many mining operations are beginning to integrate renewable energy into their systems, including solar, wind, and hydroelectric power. These alternatives reduce dependence on fossil fuels and help lower carbon emissions. Some mining farms are relocating to areas with abundant renewable energy in order to operate more efficiently and reduce strain on traditional power grids. Combining cleaner energy with energy-efficient hardware creates a much more sustainable mining ecosystem. As renewable technology becomes more accessible, greener crypto mining operations may become increasingly common. Responsible disposal and recycling remain essential for reducing the environmental impact of crypto mining hardware. Mining components contain valuable metals and materials that can often be recovered and reused if processed correctly. Without proper recycling, these materials are permanently lost, while hazardous substances risk entering landfills. Licensed recyclers play an important role in helping manage obsolete electronics safely and responsibly. Proper recycling reduces contamination risks while recovering reusable materials for future production. Governments and industry leaders can also encourage better practices through incentives such as tax benefits, grants, or carbon credits for sustainable mining efforts. Real progress requires cooperation between miners, manufacturers, recyclers, and policymakers. Let's review the key points. Traditional mining hardware creates major sustainability challenges due to high energy consumption, rapid obsolescence, and increasing electronic waste. Fortunately, alternatives exist. Energy-efficient systems like proof of stake, proof of space, and hybrid blockchain models reduce hardware dependence and environmental impact. At the same time, extending hardware lifespan through repurposing and modular upgrades can significantly reduce unnecessary waste. Renewable energy and responsible recycling practices are also essential to building a cleaner crypto future. Sustainability in cryptocurrency mining is possible, but it depends on innovation, responsibility, and smarter long-term decisions. Thank you for watching. As technology continues to evolve, sustainability must remain a priority. Responsible electronics recycling, smarter hardware management, and environmentally conscious innovation can help reduce waste while supporting future technological growth. If you would like to learn more about responsible electronics, recycling, and sustainable technology solutions, contact us today. A sustainable future for technology begins with smarter choices in recycling, energy use, and responsible innovation.